Okay, so coming back to this discussion is 9.0.2, 10.0.2. This is where Oracle software 9i will be installed. This is where Oracle software 10g will be installed. Okay, and underneath this there is a directory called as db_1, and underneath that there are so many subdirectories where the entire software is installed. Oracle 10g software is close to around 2.5 gigabytes. 9i is also like that. 11g, if you have to install, it could be the another directory there. So this kind of tells you that based on the OFA structure, on one Unix machine or one Windows machine also, you can have multiple installations of the Oracle software. A 9i software can be sitting right next to the 10g software. And then you can have one database running out of the 9i software and another database running out of the 10g software. So this is what the OFA structure is. So this directory now finally, u01 app oracle /product /10.0.2 /db1 is now called with a different name called as Oracle Home. Oracle Home is equal to, I will write it down here, u01 app oracle / since I don't have space here, I will write it down here, /product /10.0.2 let's say db_1. This directory, this is the value that should be set to variable oracle_home. So three variables that we have seen so far. One is oracle_sid, which is the name of the database that you are going to create or you are going to work on or you are going to drop. Whatever, you will be working on one database at a time. Then this is where the Oracle base is, the top level directory, and this is Oracle Home is. This is all OFA structure. So our job is to create this directory using the mkdir command. Okay, you just create u01 app oracle, that is the Oracle base, and then I think after that things will be automatically taken care of. So that is I'm going to come here now on this side. So this is where the software is installed. Now software is just a 9i software or 10g software. Using the software we are going to create the database. And database is basically data files, control files, redo files, all that stuff is database. Now let us say I am going to create a database called as a focus1 from the 10g executables. Okay, it's a 10g database. So how would I do it? Under admin, u01 app oracle admin, you are going to create a directory called as focus1. Okay. If you are going to create another database, maybe with 10g or maybe with 9i, called as focus2, you create a directory called as focus2 under admin, and underneath that you will have ora data, and then it would be p file, it would be udump.
Data will be after the Oracle base.
Yes, actually I'm gonna miss that. Yeah. So udump, bdump, cdump. Let's say cdump.
Script is there.
I think ubc, and there is adump also. Script if you want to create that, cript. So, but the important one is the bdump. From my point of view, important is the bdump. So what are these directories? We have to create these directories for our database. Background dump destination, a directory where Oracle is going to keep certain other files. Oracle is going to keep certain trace related files over here. Oracle is going to create some initialization parameter files that we'll see over here, and core dump and some scripts to create a database. So they say that please follow this guideline. So if a new DBA comes to your organization, you can go and find out things very easily. Okay. So this is what the whole thing is that. And then at this time ora data is one of them, but hold on, now I'm gonna erase this thing. What is that? Now at this time ora data, even though it is kind of recommended, many OFA guidelines say that you start with a u02, which is another mount point. Where in Unix we say it is a mount point, in Windows we say maybe it's another drive, the C drive or the D drive. So they say that some of your data files should be kept under u02 and some of your data files should be kept under u03. So how would I do it? Maybe I will keep my one control file here and my another control file over here. Maybe I will keep my first copy of the redo file over here, another copy of the redo file here, because if one drive fails, I have another drive. So they suggest that you should at least have 2 drives where you are going to keep your Oracle database related files, control, redo data files and all that stuff. So many people will follow this depending on what operation what organization you are in, or you can have another directory here, Ora data, correct? No, here under Oracle base. Okay, here, I'm sorry, Ora data, and again focus 1 and focus 2. Under focus 1 you will keep the data files, redo files, control files for focus 1, and under focus 2 you will keep the files for data files, control files, redo files over here. But as I said, many people, this is very basic in the lab environment, that everything is over here, but it is recommended that some files should go on one mount point, some files should go on other mount points. If you are working with a SAN storage, which is always storage area network, a little advanced thing, then it doesn't make sense to have 2 different mount points or 2 different drives. Everything is kind of RAID 5 or RAID 1, and then you can put everything in one, because it is not our responsibility to kind of make it safe. It is the responsibility of the storage area network administrator to create the RAID, create the mirroring, create the striping, and to keep it safe and keep it high on the performance tuning side. So depending on what you are using, we should talk about that during the performance tuning though. But right now just remember that under Oracle base there is a directory called as Ora data, and then there would be a directory called as focus. We are not going to talk about focus, focus 2, and this is where the data file should go. So here in the lab we are going to do this thing. We are going to create this directory, U01 app Oracle, and the software will be installed. The software is actually already installed there, and then we will see the installation a little later. And then actually today we are going to create the files, the data files for focus 1. So you have to create the directories underneath admin also, that udump, bdump, cdump and all that stuff. So this is the OFA, optimal flexible architecture, and now with that we will create the database called as, let us say, focus 1. Okay, you should be logged in as user Oracle, Unix user Oracle. You are going to fire the commands mkdir u01 app Oracle, then admin and slash admin slash focus 1. So this is the directory that you are going to create. If you use the mkdir -p option, then it will create this directory as well as the subdirectories in it. So you're going to create a directory called as p file. Similarly, this is the directory which is very important directory, where we are going to create one file called as a init, init focus 1.ora. This is what is called as the initialization parameter file, init file. Init file. Okay, sometimes also called as a p file. Okay, initialization parameter file or p file. This is the file that we are going to create, and in this file we are going to tell Oracle that my database block size is going to be this much, my SGA is going to be this much, my PGA is going to be this much, my shared pool is going to be this much. So all those things that we have to decide, those will be written in this file. So this is a very critical file. Even this file we tell the name of my database is going to be focus 1. So all those things we are going to type in here. So that is the init file, and to keep that init file we are going to create a directory called as p file. Then we are going to create another directory called as that inside here, bdump. Bdump is a directory called as background dump destination. Background dump destination. When Oracle instance is running, instance is again SGA and the processes. When the instance is running, let us say the LGWR process finds some problems. Maybe archival process finds some problems. So it should be giving us that information that there is some problem in this data file, there is some problem over there. All that information is now given back to the DBA through set of files. And those files are kept inside certain directories, and bdump is one of the critical directories over there. So it is a directory just like p file, in which there is a very important file called as alert focus 1, focus1.log. So we call this as an alert log file. So this file contains a lot of error messages that may be encountered by these processes. For the same reason, there is a directory called as a udump. Udump is a directory. If the error happens, if the error is logged into this file, the additional information about that error is written to another file in the udump directory. Additional information about that error is written in the udump directory, and these are therefore called as trace files, TRACE. So you should know what a trace file is. If I tell you there is some problem with the database, and if I go and say, okay, please go and check the trace files, you should know where the trace files are. I will say, please go and check the alert log file. You should know where the alert log file is. Please change the parameter in the init file or p file. You should be able to know what to change and where to go. So these are the three important directories. Along with that, background dump, user dump, then the core dump, c dump. Core dump is another directory which is where Oracle will write certain dump file, core dump files. Core dump is basically a C terminology. If a program has a major serious problem with the execution of that, it will dump a core. That means it will create a core dump file which is used by the developers to kind of find out where exactly the error has happened. These are huge files, and usually if you don't see any files created in this C dump directory, it means Oracle is working fine. So it's a good sign not to see any files over there. So B dump, U dump, C dump, script directory. Okay. So mkdir scripts directory, and we are going to whatever scripts that we will create for our own benefit. For we should keep them in the scripts directory. So any other DBA can get benefited because of those scripts, and we also know that there are a lot of scripts over there. So we are going to create a script called as crdb.sql. It's an SQL script to create a database, and we'll keep it over there. So these are the directories that you should create using the mkdir command once you log in as user Oracle. Obviously, therefore, the owner of these directories would be user Oracle. So this is step number 1 in database creation. The directories are created. Now the next thing is you have to create the init file. You have to create the init file. The name of the init file is going to be init focus1.ora. You should create this file using VI, or if you are on Windows, you should use Notepad or whatever. It's a text file, and in that, what we say that there are the initialization parameters for our database. So what are the initialization parameters you are going to write into this file? I will just write them over here. So this is my file. So first thing is db_name is equal to OCUS1. So the name of the database that you are going to write is db_name. That should be written in this file. So this is a file which has a parameter, the equal to sign and the value. Parameter, equal to sign and the value. You have to type them. Don't make any mistakes over here, because if these parameters are misspelled, then Oracle will not know what that parameter is. Then db_block_size. This is the size of the block. So I'm going to say 2048 here. Our block is a 2K block size. Then I'm going to tell my init.ora file background ck dump d_dest background_dump_dest. That is going to be equal to the name of the directory that we have just created, which is the bdump. The whole name you are going to write u01 app oracle and finally bdump. Okay, that directory should be created before this. Then core dump destination, CORE. So we are telling Oracle that name of my database is this. My database block size that we are going to create is going to be this. The background dump destination directory for your background, your files that you will be creating is going to be this. The core dump destination where you will be dumping the core files is going to be this. So again, u01 app, all that stuff, and cdump, the directory that we have created. Okay, and then we are going to say, let us say SGA target. SGA target is the size of my SGA. So let us say SGA target, I have kept it very small, maybe 290 megabytes. The whole SGA, that box at the top, which contains the shared pool, which contains the buffer cache, which contains everything, the size of that is going to be 290 megabytes. in this case, which he has not yet created, but it is going to be like that. So that is the area, that is the initialization parameter that I am going to create. Then PGA aggregate target. I'm going to say PGA aggregate target is only 50 megabytes. What is the meaning of PGA aggregate target of 50 megabytes? It means if I have 10 users connected to my database, for each of those 10 users there will be a dedicated server process running. Each of that dedicated server process, there will be that PGA, program global area, assigned to that. Now all those 10 users clubbed together, their collective, their added PGA will not exceed more than 50 megabytes. Collective, not just one for one user, not just for one dedicated process. For all of them together, it will not grow more than 50. So how do you decide these factors? Let us say I have a machine, for ease of mathematical calculation, I have a machine with 1 GB of RAM. Now 1 GB of RAM, operating system takes certain 20%, so 200 are gone to the operating system. You can find out how much of RAM you have using the free command on the Unix machine, or on Windows you can go to the task manager. So once you have found out it is 1 gigabyte, and if you are going to run only one database instance on that machine, and so out of 1 gigabyte, 200 meg is gone to the OS, so remaining is 800 megabytes. So I can decide now, out of this I am going to use what for the SGA and what for the PGA. Usually the rule of thumb is around 3 to 4 megabytes per user per PGA. So 3 to 4 megabytes of a PGA per user. So if I am going to have around 100 users getting connected, assuming that, let us say 3 megabytes I am going to assume. So 3 multiplied by 100, that is 300 megabytes. I am going to put it over here. And therefore what is remaining now? 500 is remaining. So I can utilize up to 500, not advisable to go so close. So maybe little less than 500, maybe 400 for my SGA. there. Repeat this thing. So I have 1 gigabyte of RAM on my machine. Out of that, 200 megabytes is taken by the operating system and other programs. Other programs could be maybe a web server running on that machine, maybe a HTTP server running on that machine. Assuming that certain is running, a certain memory is taken by that, by other programs. How can you find that out? Go to the free command. It will tell you how much you have and how much is taken before even the database is started. Then whatever is remaining, you are going to assign certain part of that to the PGA. PGA is clubbed together all the users, and SGA, which is one chunk. Now before you do the allocation of 800 megabytes into the PGA and SGA, you need to know how many users are going to get connected to your database at a time. Your database users may be 1000, but at a time, if only 100 users are going to get connected, 100 dedicated server processes will be there. For each of those dedicated server processes, there will be a PGA. Usually 3 megabytes to 4 megabytes of a PGA should be allocated, will be enough for a normal user to do its operation. Sometimes it may not be enough, and sometimes it is over enough. How do we decide that? We actually decide that after the database is created, and we do some performance assessment at that time. But start with 3 to 4 megabytes initially for each user. Assuming 3 megabytes for those 100 users, that is what 300 megabytes is. And then the remaining is now for the SGA. That is how it would go.
Is there an instance?
If instead of 100 users, 10 users are using, through the
only 10 users server process,
then 30 per.
No. Then you should allocate less amount, for the.
Suppose instead of 100, there are 100 users, but instead of 100 users,
only 10 are connected.
Users are using through server process. So it will go from 3 megabyte to 30 megabyte per user.
Okay. In that situation, it will not go to 30 megabytes suddenly. It will be allocated based on their need. If you have not done any kind of sorting, then suddenly your PGA will not be that much.
Yeah, that's the concern. If they are using 30 megabyte, then if 11th user comes in.
If the 11th user comes in, then these users will be shrunken. So
if all of them are using their whole memory space, then how?
So this is where the Oracle has a great advantage over here. What we are saying that you must utilize the memory for 100 users, or let us say whatever those users, within this size. If some users require more memory at a certain time because they are doing a lot of index building operation or a sorting operation, then increase their PGA for their dedicated server process. But you cannot just increase their PGA, you have to shrink somebody else's. So whichever dedicated server process is going to require that, increases and shrink somebody else's. But everything should be fitted into that 300 megabytes. And in earlier days, this was a problem with Oracle 9i and earlier things, 8i, that there was no initialization parameter called as PGA aggregate target. The initialization parameter was not there, so we have to say sort area is half a megabyte, hash area is something else, and then we will say that each user will get 4 megabytes and that's it. It will never grow and never shrink, and that would create problems for us. But now because of the aggregation here, the Oracle will happily manage all the PGAs within 300, and some will be growing, some will be shrinking depending on their need. But
why are they shrinking? Because on the contrary, they have temporary table space also, no?
So if after doing all this stuff, PGA is still less, then temporary table space. Now this is for 10G. Now in 11G, they have said that don't use these parameters. There is another initialization parameter called as memory target. And memory target is, let us say, 700 megabytes. So what is the memory target? It means your combined PGAs of all the users plus your SGA will fit into 700 megabytes, and depending on the need, if the PGA requirement is higher, PGAs will grow and SGA will shrink. If the SGA requirement is higher, SGA will grow and PGAs will shrink. That is what automatically happens. And here also, let us say we are not using 11G now, we are just using 10G. Even in the SGA target of 400 megabytes, sometimes there is a requirement of higher buffer cache and lower shared pool size wise. So that will automatically happen within this 400 megabytes.
Job scheduling.
But it's not job scheduling. Job scheduling is a totally different animal. But depending on the need, sometimes if the buffer cache requirement is high, the Oracle will grow the size of the buffer cache and it has to shrink some other sizes. And then it will do the same thing a little later. So this is currently the 10G thing. Okay, so these are the initialization parameters that you are going to put in your init.ora file. Now certain other initialization parameters that you need to put, there is the undo management _management is equal to auto. So automatically manage the undo table space, the sizing of the segments inside the undo table space. Let me repeat this. Automatically manage the sizes of the undo segments inside the undo table space. So when the data is moved from one table to the undo segment, that undo segment will grow. When we do a rollback or a commit, that undo segment is not required, so it will shrink. So this growth and shrinking of the undo segments inside the undo table space is automatically managed. In the earlier days, it was not automatic, and the time was very bad that time. And so these are the parameters. I will write certain other parameters at the top. So undo table space, undo management is auto, and then undo table space is equal to, let us say, undo TS1 or UTS1. So when we create our database now, our database has not been created yet. At that time, we are going to create a table space called as UTS1, and that will be the undo table space. We'll have to create one temporary table space. We have to create one undo table space, we have to create one system, and we have to create sysocs. At least those 4 table spaces we are going to create. The name of the undo table space that we will create at that time will be UTS1. So these are certain parameters, and the most important parameter is now control _ files. So we are going to tell now our database, which has not been created yet, no control files are there, no redo files are there, no data files are there, but which control files we are going to create, their names are going to be written over here. So if you are on the Windows, you can say c:\control1.ctl, extension name doesn't matter, comma, then you can give another name, you can give third name. So let us say, I'm going to use only one name, which is very dangerous, because if this control file is lost, then we are in a very bad shape. So usually you will put at least two names over here, comma, and then on the same line you will say maybe d:\control2.ctl. So this is 1.ctl, this is 2.ctl. So control files is equal to at least comma separated list of files. The whole name should be there. So you are going to give what name? You are going to give u01 app oracle focus1, then ora data and control1. That is what the name that you are going to give, and control2, both of them you're going to keep in the same directory then. So this is the control files, and I think these are enough parameters right now. So we are going to create this file. We're going to type all this stuff in the file called as init focus1.ora. Init, which one? Compatible. Okay, I forgot the compatible parameter. Compatible is going to be, in this case, let us say 10.2.0. You can put the version of the parameter, and this will tell that this is an Oracle parameter, the Oracle compatibility parameter of 10.2. Once the compatibility parameter is set to a certain version, it cannot go down. Okay, so you cannot use different features over there. You cannot change, certain parameters cannot be changed once they are created. Which one is that? DB block size. Once you decide that it is going to be 2K, it is going to be 2K until and unless we recreate the database with something else. So this is also one of them. It cannot come down. So and there are certain other, there are around I think 300 different initialization parameters. 300. All these initialization parameters can be found out if you go to an existing database, can be found out in a view called as $parameter. $parameter is a view which will show you if you are logged on to current existing database. Just do a select star from $parameter. It will show you a value and it will show you the actual thing. So, so we'll take a 5-minute break here.